Welcome back to this fifth and final episode of Westgate Beyond the Collapse. Over the past 4 episodes, we've examined the history of the Westgate Bridge, from its ambitious beginnings in its early planning stages during the 1950s and 60s, through to the tragedy of October 1970, and the subsequent engineering advancements in strengthening and increasing its capacity following the decades after its opening. Today, we shift the focus to the Westgate Tunnel, a modern engineering solution that builds upon these lessons to address Melbourne's growing transport needs, but also, in some degree, bring about the alternative option to the Westgate Bridge from all those decades ago. That's right, a tunnel. Only this time, it was chosen to direct traffic to a new junction point within the CBD, rather than detour around it. The Westgate Tunnel project is not merely an alternative route. It's intended to be a transformative investment designed to support a continuing expanding city, alleviating traffic congestion and improving freight movement by getting heavy vehicles off local roadways. Let's explore the design challenges and the potential of this ambitious project. Since its completion and opening in late 1978, the Westgate Bridge has been Melbourne's most crucial east-west link. Yet, with now over 200,000 vehicles crossing the bridge daily, far beyond its original 1978 capacity of 160,000, it has now become a bottleneck for daily commuters and freight alike. Congestion, delays, and heavy traffic on nearby residential streets has long been known in recent decades and highlighted the need for an alternative route to the Westgate Bridge. The Victorian Government, in partnership with Transurban, proposed the Westgate Tunnel to address these challenges. By providing an alternative route to the Westgate Bridge, the tunnel would seek to reduce traffic congestion, improve freight efficiency, and enhance connectivity between Melbourne's western suburbs, the ports, and the CBD. The Westgate Tunnel project, a $10 billion infrastructure initiative, was further developed as a solution to these challenges. It provides a second river crossing and means of entering Melbourne's CBD, and more importantly, a direct route to the ports of Melbourne, taking trucks off the lesser roadways and also potentially supporting future urban growth in many of Melbourne's western suburbs. At the heart of the project are the two 3-lane tunnels, each stretching approximately 4 kilometres under Yarraville. These tunnels offer a second direct link between the Westgate Freeway and the CityLink network, the former being on the eastern side of the Birrarung, effectively bypassing many residential streets. At each outlet portal of the two tunnels, large towering structures are being built. These housing ventilation systems to extract exhaust fumes. Their dispersion capability having been modelled to ensure that air quality is either maintained or improved, with the trucks no longer traversing through former residential streets. Provision, however, has been made within the outlet portal structures for additional particulate filtration units to be installed, should these modelling conditions not reflect those of real life. At the moment, these filters don't appear to be needed immediately. Instead, I understand a trialling period will take place to assess the overall dispersion effectiveness before findings are then reviewed by the EPA and direction given as to their need. The project also has included the widening of the Westgate Freeway itself to 12 lanes, seeking to ease former bottlenecks and improve traffic flow between the original Westgate Bridge and these future tunnels. An elevated roadway along Footscray Road also connects the tunnels directly to the ports of Melbourne, and also to its central business district via Wurundjeri Way, facilitating smooth freight movement while reducing the impact on local neighbourhoods such as Yarraville and Footscray. Project management and the engineering behind a project of this scale always presents numerous challenges, particularly with tunnelling under an urban environment. The geological conditions under Yarraville and Melbourne in general are incredibly complex, ranging from silty clays to basaltic rock layers, not to mention a typically shallow water table. Some of these rock layers being incredibly hard to break through, whilst others can be prone to liquefying without a great amount of warning once disturbed. These conditions require detailed geotechnical investigations to guide the design and excavation methods. Even then, with this information on hand, surprises still happened, like this below-ground river occurring when they were linking the two tunnels to create an emergency pathway in the event evacuation should ever be needed within these tunnel systems. To excavate the tunnels, two massive tunnel boring machines, or TBMs, each over 15 metres in diameter, were deployed. These machines are amongst the largest used in the Southern Hemisphere to date. They are equipped with advanced soil conditioning systems which stabilise the ever-varying ground in front of the machines, and real-time monitoring systems to ensure stability of the machine and permit alignment tolerances to be achieved. Precision of these machines is critical, especially to minimise settlement risks and protect nearby structures. After all, you can see the alignment of both tunnels goes under many, many residential houses, railway lines, and many further commercial and industrial buildings, let alone Stony Creek and the Maribyrnong River. Talk about an ever-changing landscape, albeit one in the dark. Managing traffic conditions during construction has been another significant challenge. Maintaining operations on the Westgate Freeway while carrying out major upgrades has required dynamic traffic controls, night works, and carefully planned detours to minimise disruptions for commuters. I live nearby to the works, and it's pretty hard not to see what's going on and how it's impacting residents in the short term throughout the works construction. Beyond its engineering innovations with the tunnels, viaducts, veloway, and numerous other roadway upgrades, the Westgate Tunnel project reflects a strong commitment to sustainability and community engagement. To offset the removal of trees along the project alignment, nearly 1 million trees will be planted in the surrounding areas as part of a 5-to-1 replacement program. Excavated material from the tunnelling process is being repurposed wherever possible, with strict protocols in place for managing contaminated soil where it's encountered, including any concerning materials containing PFAS or remnant asbestos from bygone eras. Community feedback has shaped many aspects of the project, from noise barriers and their design to pedestrian and cycling infrastructure. The veloway mentioned before is an elevated cycling path along Footscray Road, offering a safe and convenient route for cyclists travelling between Melbourne's western suburbs and the CBD. Linking up to other cycling routes such as the Federation Trail, which follows much of the former main outfall sewer from the Melbourne Metropolitan Board of Works, which I'll aim to present on under a separate series. Once completed, the Westgate Tunnel will fundamentally reshape Melbourne's transport network, similar to how CityLink did just that prior to the turn of the century. By providing an alternative to the Westgate Bridge, the project will significantly reduce congestion, with projected travel time savings of up to 20 minutes for many commuters. Dedicated freight lanes will remove thousands of trucks from residential streets daily, enhancing safety and livability for local communities, especially those throughout Footscray and Yarraville, where many trucks travel in order to access the Westgate Freeway from the exits of Melbourne's ports. This initiative should support Melbourne's ongoing economic growth, improve access to the ports of Melbourne, and hopefully reduce logistical costs for industries reliant on freight transport. The inclusion of modern safety features, upgraded intersections, and separated cycling infrastructure ensures that the benefits extend beyond vehicles to all road users and local residents nearby the works. The Westgate Tunnel project represents a culmination of decades of engineering progress and lessons learned, many from disasters like that of the Westgate Bridge, only within eyeshot of the new tunnel works, through to many other projects across Australia and the world. From the Westgate Bridge's inception to the tunnels being constructed today north of its position within Melbourne, these projects highlight the vital role of infrastructure in shaping our cities and improving our lives. I do find it remarkable that the early debate on whether a bridge or a tunnel would provide Melbourne with the best outcome started with a bridge being the front runner, only for a tunnel to follow suit less than 50 years following the bridge's opening. That may be more due to how far engineering has advanced in the time between and the technology which can be applied to any challenge identified. Concluding this series, I reflect on the ingenuity, the resilience, and the collaboration that have had to happen to define Melbourne's transport system as it is. It's tragic that so many lives were lost more than 50 years ago, but gratefully, many lessons were learnt and, more critically, not forgotten. In some ways, trying to, as best possible, respect the terrible events of that day on October 15th, 1970. I'm Paul Michael Angus, mechanical and civil engineer. Thank you once again for joining me on this journey through the evolution of this transport initiative in Westgate beyond the collapse.